So what do we got?
We got some Weber carburetors.
What are they out of?
They are out of a 250 Lusso.
Ooh.
These versions are called the 36 DCS.
So are you recording all of the nefarious activities?
There you go, 36 DCS.
Okay.
Weber carburetors are also serial numbered.
Yeah.
Okay, like they're more like batch numbers, because I can promise you the guys at the Weber factory and the guys at the Ferrari factory don't try really hard to match. So you see, like, that's a 2100, that's a 2500,
Yep.
that's a 2800. You know, you see there's some continuity there, but it's not like these are three carburetors that were stamped in a row.
Right,
and
right.
put
It
in a
didn't go
box.
1, 2, 3 and then shoved in that car.
Exactly. The Lusso, it's a pretty nice car. It was restored. It was done pretty well, it seems, and all of that. But like a lot of these cars, after they get that kind of work, it was probably driven a couple of times and then parked for several years.
And then the fuel went to crap.
Yep. Local gentleman's bought it, you know, and wanted to go drive it around. And of course, it's not running on all 12 cylinders and, you know, won't idle right and all kinds of weird stuff. It didn't run right, so it's all plugged up. He's got a nice big air-conditioned warehouse, so it was easier for everybody for me to go down there and spend a couple hours and pull the carburetors off the motor and bring them to the shop and go through the process of servicing them. And then I'll go put them back on the car and we'll do some base settings and stuff there on the car at the warehouse.
Nice.
Instead of trucking it back and forth.
Are those already rebuilt then?
Yeah, so these
Okay.
are finished carburetors. Couple little things, you notice some glue on these are called fiber washers.
Okay.
Okay, so they're not metal, right? They're not rubber. They're not technically paper. They're a fiber material. One of the problems we have is in the old days they were thicker, you know, different material. And now that these carburetors are 60 years old, none of the surfaces and stuff are as nice as they once were.
Yeah, they're not really flat anymore.
No, and it's kind of a big deal to start machining these things and trying to cut it all and get it all nice again. So I've started using a fuel-resistant sealant that's used for fuel, you know, sealing all kinds of fuel tanks and industrial applications and fuel lines. The problem is there's a brass threaded insert that goes into this aluminum case. So when something's leaking, our natural tendency is put a little crank on it. After a while, you start tearing all the aluminum, you start pulling that insert out, and now, you know, shit starts rolling downhill.
Yep.
So you can get to a point where you have no choice but to start remachining all of this. And we've seen that a few times, but this is just an easy way to kind of prevent anything like that happening. And this is not a show car. It's not a museum car. The gentleman owns this actually wants to drive it around town and have fun with it. So we're not concerned about it, you know, being
Perfect, yeah.
perfect in every aesthetic sense. Because the fact of the matter is when the airbox goes on and all the fuel lines are on, you're never going to see any of that stuff. So
Yep.
we're more worried about
Functionality.
Yeah. You get fuel leak, obviously that's dangerous for the car and everything, so we don't want fuel leaking anywhere. The nice thing is, you know, they haven't seen heat and fuel and all of that. You know, the gaskets are all nice and soft, so we can pop these all back apart, because the fact of the matter is when we're rejetting these carburetors while tuning, these tops will come off multiple times, and you're not going to replace the gaskets every single time the top comes off, so it's really not a big deal to pop these apart, even though it's all been reassembled. The only thing we won't take apart is obviously that piece there that's glued. A lot going on to a carburetor we don't always realize, so they're just kind of fun to talk about, honestly.
Oop, there it goes.
There we go. So here's kind of the essence of the carburetor, right? Here's what we call the fuel bowl, right?
Okay.
So the carburetors actually store fuel.
Some extra fuel, yeah.
Yep. You've got a float here.
Yep.
So the fuel will actually flow through this, right? Fill the bowl, just like a toilet, basically, right?
And it's
Shuts it off. You know, in calibration, these needles have different sizes to allow certain amounts of fuel flow. This is a 1.75 millimeter diameter. These floats have a specific weight to them.
okay.
Which means they react to the fuel level at a different rate, right? If this is heavier, it's going to react more slowly
Yep.
to the fuel. So when you're rebuilding carburetors and making sure that they're calibrated properly, you want to make sure you've got the correct needle size. Also, the seal ring and the distance between the valve and the body should be a particular height, so that way you have a particular range of motion. There's a tab here and a tab here. Those are bendable tabs to also make sure that, as you can see, when the float drops, right, tab hits the body there. So that's a minimum amount of droop. that tab that pushes on it there, right? You can bend that, and that will determine the height of the float as it's running the valve open and close as well. So there's a few different points of calibration there that you need to check, verify, maintain for the carburetor to work either the way it was designed to or in a modified engine, right? Recalibrating
for
this stuff.
what its current capacity is.
Exactly. And then another problem you can have, since these are brass floats and they're all soldered together, sometimes the solder joints fail and you get pinholes, and then the float
Fill up with
Yep.
gas and it doesn't exactly float no more.
Exactly. And then you get a carburetor overflowing with fuel. There's a few different ways to measure things like float heights depending on the carburetor and whatnot. A lot of them are intended to be measured without the gasket. Some of them are intended to be measured with the gasket. But usually you're measuring from the body to here is where Weber sets up your tolerance. But in this case, we actually measure the distance with feeler gauges between the top of the float and the body. So on this specific carburetor, that would be 10 millimeters, and that would be 3 millimeters for 7 millimeter total stroke from full open to full close.
Gotcha.
A carburetor works with two basic principles, right? The gravity of the weight of the fuel, right? So the quantity of fuel in the bowl determines how much fuel is in these areas here. We call them wells. This would be an emulsion tube, right? And an air corrector. So that well there will be full of fuel.
Yep.
The height of the float determines how much fuel is here. This is your equilibrium. If your fuel bowl is up, it's gonna balance out, right? Your fuel bowl drops, it's gonna balance out. So it's very critical to get your float heights correct for your engine, to make sure your fuel level in the well is correct to match up with the holes machined in the emulsion tube. That's what's crazy about the carburetors. It's technically simple, right? So you have the fuel level in the float bowl / the emulsion tube well, but then you also have the airflow through the carburetor, right?
Yeah.
Suction of air determines how much physical fuel.
It'll suck in, yeah.
Yeah, so on one hand, it's super simple, right? But all the stuff that goes on in this carburetor to make all that super simple stuff happen is actually pretty complicated. These are little lead shot BBs that are driven into the carburetor body.
Yep.
And they're all over, right?
Okay.
These are machine pathways. So this was so that way a machine could drill through the body here, drill through the body here, drill through the body here, etc., etc. These are the pathways in which the fuel moves through the carburetor, right? Because it's stored in the bowl.
Yep.
It's got to go into the emulsion tube well, and then it's got to get through the idle jet up here, the main jet over here, and then we also have what's called the progression circuit with machine holes there.
Cool.
Okay? So
Very small.
Yeah. So that's why carburetors kind of need frequent service and
I could
fuel
see
quality.
that tiny little hole clog pretty easily.
Very easily.
Yeah.
Yep. And that's
Especially
why
some old fuel.
exactly. And that's why most of the time when carburetors are not working correct, it's at idle and below 2000 RPM, because that's your idle circuit or your low speed running circuit, which is all these small machine pathways which get gunked up very easily. Once you get to the main circuit, a larger pathway for the fuel, and obviously a lot more air velocity, because now you're running at 3, 4, 5, 6, 7,000 engine RPM, so it's easier for it to draw that fuel through.
Right.
So the main circuit is a lot less sensitive than your idle or low speed circuits. And that was the case with these carburetors. The low speed circuits are all gunked up. If you just whack the throttle, half, 60, 75%, brought the revs up to 3, 4,000 and drove like a madman, car ran great. But if you wanted to just pull out of the parking space and move across the parking lot, pleasantly, or gently pull out of a driveway onto the street, you feel like you're going to end up getting run over.
How do you clear those out? Because those are really small.
Yeah. So
Because I'm assuming that's what you got to do, right?
Correct.
You take out all this stuff and then kind of poke something through those holes?
Well, so there's a couple different ways that you can clean them, and it kind of depends on how bad they are, right? Knowing that these carburetors aren't too bad, what I did is I have a 5-gallon bucket of Berryman's Chem Dip, old-timey super caustic solution. And what we do is we take everything out of the carburetor that can be removed with, you know, this wrench and screwdriver. And then I put a little lead on the carburetor and I dunk it into the chemical bucket for about an hour or so, because these ones, you know, weren't in terrible condition.
Yeah.
And I let it, you know, because now the chemical is going to get into all the passageways and eat at all that stuff. And then once it comes out, spray it all down with carbon choke cleaner or brake cleaner, you know, some sort of aerosol solvent, and then run shop air through every one of these little passages that is open, and check and see where all the air's coming through, and make sure within reason there's a, you know, good
Some
air
flow, yeah.
Yeah. Same thing with the actual jets themselves. So like this is the idle jet here. This is a 2-piece. This is just the holder. This is the actual idle jet.
Okay.
So you can see you've got a couple small holes here. These would be your feeds, and this would be your outlet here.
Okay.
For reference, this hole is 0.55 millimeters in diameter.
Pretty tiny.
Yep. Once you soak it in chemical, you can actually see light through the jet. Like I can actually see you through there.
Yeah.
And also what I'll do is take that aerosol and blast it through there and make sure that it'll actually pass some fluid. Blast it with some shop air. Same thing with this. We'll blast this all out, make sure there's no gunk built up in the bottom of that, you know, because this is a dead end here, right?
Yep.
So we'll blast that all out, put it back together, you know, blast air through here, make sure we got air coming out of all the places in the carburetor where the idle circuit wants to pass air. And then we thread it back in with a fresh sealing ring to make sure there's no vacuum leak, because that idle, right, vacuum is very sensitive. For any engine, even on your 458, a vacuum leak will make it run poorly.
Yeah.
Same
Ask
thing
us
with
how we
this.
know.
Been there, done that. A few other things going in. You know, there's what's called a pump, which is this guy. So when you whack the throttle, see this?
Yep.
That forces liquid fuel, not emulsified fuel, liquid fuel out these little guys and blows it straight down the throats. That's your fast acceleration enrichment. Every engine has some variation of this. So if you're using an air fuel meter, let's say you're just cruising along, you know, you're just driving whatever, and you need, you know, your air fuel ratio is like 13.2, right? It's a good engine performance, but it's not enough to like make power. You whack the throttle and the pump squirts, all of a sudden it's going to enrich into like a 10.5 or an 11 or, you know, whatever it's calibrated to make sure there's an excess of fuel for the engine to capitalize on, make immediate power with no detonation and misfiring. And then it will lean itself out as it starts, you know, because this is just a momentary shot. And then it goes through the motor and out the tailpipe, and then you go back through just your idle or main jet circuits. So that's another component that's important, to make sure that it is clean and calibrated. Because if this pump shot is too rich or too lean, when you stab the throttle, the engine will hesitate. It can both rich and lean hesitate.
I learned a lot today already.
The other thing that's really interesting, right, about Weber carburetors is this is a 36 millimeter diameter throttle plate and float. Okay. What you will notice though is this is what is called a venturi or a choke. It says 27. So the ID of this is 27 millimeters.
A little bit smaller.
Yep. So one of the principles of a carburetor, right, is acceleration of airspeed to get it to actually create a negative pressure or a suction. This is a 36 millimeter throat carburetor to flow, you know, X amount of air for X amount of horsepower, but to get the airspeed up for that negative pressure to actually draw the fuel, you run this choke. Because what you do with the air, right, is you squeeze it and then you let it expand, and that expansion causes an acceleration of the air, creates a negative pressure, sucks the fuel out of the carburetor. So one of the other tuning things you can do is change the size of these throats. Right? If you want better torque and low RPM response, you run a smaller choke. And if you've got a big hot rod motor that's all big RPM, you will put a larger choke in there. Because at higher engine speeds, just the natural airflow through the carburetor, you know, is usually pretty adequate. And plus, obviously, by opening that up, you increase the actual, you know, CFM or airflow through the carburetor. Smaller choke is going to be less air, you know, moving through. So that's a calibration point. These guys are a calibration point as well, but to be honest, almost all of these Webers kind of use the same like 1 or 2 sizes. There's very little variation in the auxiliary here. It's not really, you know, a big talking point. You can see the throttle shafts, right, run perpendicular.
Yep.
On most Webers that most people would have worked on, like the DCN series or a DCOE, the throttle shaft actually runs this way. So you have one common shaft.
One shaft.
Yep. So on those carburetors, you have your idle mixture adjustment, and you'd have a single linkage adjustment for your opening and closing your rest position, right? And then you'd have extra little screws like these guys here and here. And these are air bleeds, and that's what we would adjust to balance to make sure the airflow going through each throat is the same. But on this, because it's got 2 perpendicular shafts, we don't have those bleeds. So you see there's a clamp with kind of a complicated fixture here. And if you look, there's a little geared arm in there.
Yep.
See that?
Whoa. Yeah.
So the throttle linkage only connects to this point, and this operates that. So we have to balance the throttle plates to each other. So that's kind of a cool thing on these early carburetors that's also specific that they changed in later ones. When I tore all of these carburetors all the way down and cleaned them all up and all of that stuff, what I did to save time running it on the engine is I have a shop vac apparatus, which I'm not really concerned about the specific airflow through the carburetor. It's just a known non-variable source. So the vacuum always flows, let's say 24 CFM all day long, every day. It doesn't matter if it's Wednesday, if it's 100 out, if it's 46, doesn't matter. It always flows the exact same amount of air. So in this case, what I would do is, and I did, is set up on the master throttle, set my adjustment for the blade and open the blade to, you know, where I wanted it to be. And then I measured this guy, and most of these were flowing a lot less than this side. So with it flowing, now I open this side and then set it so they match, and then clamp it down. So that way I know whether it flows too much or too little.
They're both the same.
They're both the same. So when I put these carburetors on the engine, I should be quite close. You know, it's never going to be perfect.
Do you need to make sure that this carburetor matches that carburetor?
Again, it helps simplify the process when it's on the engine, because what I will do is, and so I did that for each one of these. So all 3 of these carburetors, each 6 of these throats, all flow 4 kilograms an hour using the shop vac and 1 measuring tool. So all 6 throats are calibrated exactly the same, you know, to the T.
Gotcha.
Whether that, you know, is the same on the engine, we don't know, because you got compression, you know, temperature different, you know, there's a V12.
A lot of variables.
Yeah, a lot of variables in an old V12 engine. So the flow that these did on the bench, I don't expect to be the same when they're on the engine. But the point is now instead of having to use fine tools to get the engine running, right? Because that's the concern, is after having these all the way apart and back together and you go throw them on the engine, you can't immediately tune it because the engine's cold and it doesn't run properly.
Right.
So you got to get the engine to a minimum condition to run.
To warm it up.
To get it warm. And then you can start measuring and see what your air-fuel ratio is and what your airflow
Well, it also
is.
seems like then, let's say you figure out this one needs to be adjusted, well then all 3 need to be adjusted.
Theoretically.
Theoretically,
Yeah. And the point is now I know each mixture screw is 2 turns out, and each throttle is adjusted to flow 4 kilograms an hour. So yeah, in theory, if I put these on and the engine's idling at 2,500 RPM and blowing an 11.5 AFR, and I know I need to cut 1,000 RPM and cut at least a full point of AFR, then without having to use, you know, precision tools, I can just turn each screw 1 turn, bring the revs down, turn each mixture screw a half a turn, and basically make course adjustments to get the engine from all the way up here to down around here. Then I can go in, you know, and individually check each throttle and make sure each throttle is specifically flowing, you know, a balanced amount of air across the entire engine. And it's the old 80-20 rule, right?
Yeah. Get yourself 80% of the way there.
And then, we'll worry about the last 20%. But if I were to slap these on the engine the way they were without flow, test them on the bench, it would have taken all day long. I mean, the engine might not even started and run very well because the airflow imbalance from carburetor to carburetor was so erratic that it would have been a disaster. And then trying to guess and figure out, which adjustments to make and why, because airflow can be low both because you don't have enough fuel, because you have too much fuel, because you have too much airflow, and because you have not enough airflow. There's a balance. Again, there's a window of ideal operation. Once you get far enough outside of that, you can't always tell real easily which side you're on, so you got to make like really coarse adjustments and see how it reacts and go, oh, 2 turns to the left was even more in the wrong direction. So now we got to go 4 turns to the right just to get it from, way over here back over here somewhere. So doing this, it's not a perfect science. It's not a factory calibrated flow bench where I know exactly how much air and fuel should flow through this carburetor for this engine, which is what Weber, factory would have used. But I at least know that they're all going to flow about the same when they go on the engine, right, wrong, or indifferent. So it'll simplify things.
So how many of you want to see him put these on the Lusso and get it running?
Vroom.
Yeah.
Carburetors are a lot of fun, and obviously that's like a carburetor 101 introductory course.
Yeah.
There's
and you like the 500 level.
a really good guy out there is David Vizard. He's an Englishman. He's done some really cool seminars on Weber carburetors, and you can find some bootleg clips of his stuff on the internet and whatnot. So there's other guys out there that have already gone into some really fine detail on these. The purpose of this was just literally just the fun about talking about carburetors for folks that would never otherwise take the time to go learn about carburetors.
Yeah, me, I'm a fuel injected guy.
Yeah. So this is a period 60s Weber service book that I got off the internet from a nice man in Italy that somehow, acquired a bunch of this stuff. So as you can see, this is a June 15th, 1964 original printed parts diagram of the Weber 38 DCN from a 250 Testarossa, all in Italian. Here we've got a 62 GTE.
Wow.
It's really the same thing as the Lusso 36 DCS. So this is what I use as a reference point when I'm servicing these carburetors to make sure we're not missing any parts. Because you can see there's a lot of little sealing washers,
Oh yeah.
caps, nuts. There's a lot of little bits that can go into the carburetor, making sure that it's, period correct or functionally correct. Good example, right? Here's your throttle blade adjustment screw. It shows you've got a screw. And if you notice, you can tell it's both a hex head and there's a slot machined into it. And there's a capturing cup, and then you've got the spring as well. Hex head with a slot, capturing cup, and I can assure you there's a spring in there. I use these ugly green O-rings that work really well under these idle jets. When I took these carburetors apart, there were no seals here. And I know from general experience that that's going to be a vacuum leak point, and sometimes it's going to make getting a nice tune really difficult. You could argue that in the 1960s, it's not real likely that there were rubber Buna O-rings being used in cars. But what's nice here is this is the idle jet assembly here that we talked about. 22 is the idle jet, 24 is the holder, and 23, we come down here, 23, 2 of Anello di Tenuta Portagetto Minimo. Minimo Portagetto, right? Minimum jet, or as we like to say in American English, an idle jet. And obviously Anello di Tenuta would be a seal of some sort. So then you just start kind of evaluating, well, what kind of seal might there be? Is it a machine face that would take a flat seal? Is there a bevel cut? And there is. So you know that it would have taken some sort of soft seal.
Yeah.
Right? So we use O-rings. All of the late Weber carburetors use rubber O-rings. So it's reasonable to believe that there should have been a rubber O-ring in there. Even though that doesn't really look, that looks more like kind of a sleeve of who knows what material. I'm not worried about it because, again, we're not going to get judged at a concourse for points for what seal is there. We're going to use a material and a part that we commonly use in Weber carburetors.
Well, it's going to last a lot longer
Exactly.
and be more durable. And
Exactly. Yep. Which with, all the fuel we've got today, is a big concern.
yeah, all the ethanol in the fuel.
Yeah. And so, like as you can see here, this is for the 250 Testarossa, not mine. So you see, this is a gauge. This is a float height setting, right? So as we were talking about, here is your float, here's your needle valve, here's some distance values, here's some special tools to show you how to set the float height. And then in Italian, you know, here's the procedure for setting it. This is a guide on how to set these carburetors up, you know, by the book as the engine originally ran. Now, what's also super helpful in these, regulation, right? Italian for our jetting pack. So this is all of the specs for how this carburetor was set up with tuning parts from the factory. See that 27 millimeter? That's that Venturi we were talking about in the throat. 0.55, that would be the idle jet diameter we were talking about earlier. 1.75, that's your float check valve, et cetera, you know. So using this original sheet, and as I did, I checked what was in this carburetor, verified that it is tuned to factory specification. And since the gentleman who owns this car has a 300-gallon tank of 93 octane fuel with no ethanol in it that he uses specifically for his vintage car collection, I know that I don't have to rejet this carburetor to compensate for ethanol fuel. So the thing about fuel, right, is there's air-fuel ratio, but there's also what's known as brake-specific fuel consumption, BSFC. So what that means is the actual physical quantity of fuel needed to accomplish, you know, a horsepower or an air-fuel ratio, right? So with pump gas, there's a certain physical amount of fuel that has to flow to this carburetor, let's say at idle, to get a 12.5 AFR. And let's say that with a non-ethanol fuel, a 0.55 diameter idle jet is adequate for that.
Yeah.
Well, alcohol, even though it burns cooler and does some other neat stuff, it also requires a larger quantity of fuel to accomplish the same goal.
Yep.
So if this were like a lot of my regular guys, like a 308 or something, that's street driving the car, you know, running with a Ferrari club and needs to be able to stop at the local Shell station to fill up halfway through the run, we need to account for that because
bigger jet.
Yep, exactly. So I would start with a 0.60, maybe a 0.65 idle jet in order to maintain the same air-fuel ratio and engine power, because we actually have to flow physically more power. So this is a really great guide to know what should have been in this carburetor, and then when I pull it apart, that'll tell me whether or not someone either was trying to rejet the carburetor for a specific type of fuel, whether they were rejetting the carburetor because maybe this engine was built with more compression, more aggressive camshafts, you know, more RPM, you know what I mean?
Yep.
MSD ignition upgrade, which we do a lot in, you know, in the driver cars. And so they might have custom calibrated this carburetor for that specific engine and that specific fuel. So now I can look at, you know, what's in the carburetor, what would have been in the carburetor, surmise if they did something on purpose or whether they didn't know what the they were doing, which you'd be surprised how often you find some parts in a carburetor and clearly the people didn't really know what they were doing, which is complicated by the fact that things like the emulsion tubes, there used to be many thousands of options. Over time, you know, that availability has gone away. So now tuning the carburetors really, really well has gotten more difficult because there's less parts availability.
Gotcha.
So people will put some weird shit in these carburetors trying to accomplish something that you can't really accomplish. You know what I mean? You're trying to make something, you're trying to force something to work that ain't gonna
This
work.
ain't the right size, we'll make it work.
Yeah. And work means the car drives down the road.
Yeah.
You know, it's not making its best power and it's running too rich or it's running too lean, stuff like that. So it's nice having this original documentation. Just that way, now I know for sure this carburetor is assembled as per factory specification. I know the customer is using a comparable fuel, so I shouldn't have to retune and custom jet these carburetors. Now that they're clean and balanced, they should go on the engine, tune pretty nicely, and we should have a nice running and driving 250 Lusso with just very basic service work done to it, no reinventing the wheel.
Very cool. So we're gonna be going and installing the carbs. Well, actually, Josh is gonna install the carbs, but then I'm gonna go over and visit when he's tuning them. So we're gonna actually get to see him tune those 3 Weber carburetors on a V12 Ferrari. That's gonna be pretty cool. Different scenery for once. Look at that. A Lamborghini took the place of my spot on the left. It's kind of nice to actually see other cars rather than my 599 here in its sad state of total torn apartness and dustiness. By the way, if you need any services from Josh, go check out exotic-power.com. So that is his new website. It's actually very nice. So he does obviously a lot of work on a lot of different exotics. So pretty much any exotic you can think of, he can get you set up. So hit him up if you need something. We have lots more car stuff coming your way, so you're gonna wanna stay tuned. It's gonna be sweet.